Good morning, Internet. This is Alex the Sudokus, and it is Friday, the 25th of September 2020. Happy Friday, everyone. We have another medium New York Times Sudoku for you, and let's jump right in. We're just going to do it normally today, so I can take my time to explain the techniques used. To start with, we're going to use Snyder notations to solve this. And by that, what we mean is we are going to use the numbers. We're going to look at the numbers and see what rows and columns they look into the other cages. Cages, by my definition, is a grid of 9 cells. So that forms a cage. Individual squares, I call them cells. And I don't know, I'll use other terminologies later. So anyway, so for example, when we talk about Snyder notations and pencil marking 2 candidates at a time, if we look at this cage, the one takes up that cell, this one sees those 2 cells, so we've got 2 possibilities of where the 1 can go in this cage, and that's my 2 candidates basically. So whilst we're here, we actually formed a pointer pair of 1s, and a pointer pair is basically when 2 of the same numbers are lined up in a row or a column, and they have the if they are lined up as within the cage, if the only candidates are forming a line, then they essentially mean outside of this cage, the same number cannot exist in the same column or the row, basically, depending on how they're lined up. So they basically point in a direction, so to speak. So this pointed pair basically eliminates these 3 cells as 1s, because 1 has to be in one of these 2 cells within this cage, so there's no way there can be another 1 occupying the same column. So now that basically forces me with a pair of 1s in this column, but since 3 takes up the middle row, I've got my 2 candidates here that I can pencil mark in. So hopefully that makes sense, and I will name more examples going forward. But other than that, it looks like all the 1s that I can pencil mark in are pencil marked in. In all the remaining cages, I've got 3 candidates here, 3 candidates here, 3 candidates there, 4 candidates here, so I'm not going to pencil mark them in using the technique known as Snyder notations, basically, or the methodology. So let's look at 2s instead. If we look at these 2s, well, they lock a 2 over here in this cell because the 2 columns are taken and the row is taken at the bottom here, so 2 has to be in here. So now that unlocks a pair of 2s over here, so we can pencil mark them in because it's a pair. But if we look at this cage, the 2 sees these 2 cells. I've got 3 candidates there, so I can't pencil mark them in. So let's leave them for now and continue on. So I think that's all the 2s that I can pencil mark in, actually. So let's move on to 3s. I can see a 3 over here because of these 2 3s taking up the rows, leaving me a 3 on this column, basically. Well, in this cell specifically. Can I do anything else with the 3s? It doesn't look like we can. So I've got 3 candidates there. I've got 3 candidates there. And I've got 5 candidates. 4 candidates, 4 candidates. So it's not worth pencil marking them in for now. But we will come back to them at some point. Okay, if we look at 4s, these 2 4s locks a pair of 4s in pencil marking over here. But what's interesting here is if we look at this 4, it locks these 2 cells in this cage. That gives me 3 possibilities of where the 4 can be. However, whilst I'm not going to pencil mark them in, I can tell that this column is now occupied by the 4, which means the 4 can't go up here at all in these 3 cells, just like the 1 is a pointed triple. Even though I haven't pencil marked them in, I can use them to rule out the 4s. And this is why when I do Snyder notations, I typically follow the numbers one at a time. More experienced players can just look at the grid in general and just place candidates, but I like to be quite systematic, and by focusing on a single number at a time, I can ensure that I don't miss these invisible pointed triples that I'm not normally going to pencil mark in. Some people, they would choose to pencil mark them in if they form a line, but for me, I like to keep the grid as simple as possible, because if I ever do it on pen and paper, I like to leave the least amount of pencil markings as possible, basically. So, with all that waffling, let's move on. So we have a bit of an intermediate technique going on here now. So if we look at this 4 and this cage, the 4s are in these 4 cells. Again, we can't pencil mark them in based on the Snyder notation technique. But what we have noticed is they are locked in rows 1 and 3 in this cage. And what I like to do is when I have these situations, I will pan around to the, in this case, I looked up with the 4, so I'm going to pan around horizontally to see if I can see any 4s locked down in the same columns. And I do, because in this case, the 4s are pencil marked in these 2 columns. So that forms a pattern where the 4s has to be in these 2 rows within these 2 cages. So whilst pointed pairs focuses on just a single cage effect on others, when you've got these situations, when you've got 2 numbers locked in 2 rows, that's in effect the same as the pointed pairs in a single column, except this time you're doing it on 2 columns instead, 2 columns or rows in this case. So it basically means the 4s has to be in row 2 in the final cage, because if the 4s are here, then I've got to put a 4 in this row somewhere, but it can't be in these 2 cages, so it has to be in the last cage. So yeah, it just so happens that it is locked in 2 cells, so I can pencil mark them in. If that 1 wasn't there as well, then I'll have a triple, and I'll end up debating whether to pencil mark them in or not. And in this case, we can just do it. So I pencil mark them in. So I hope that made sense. Please leave a comment if my explanations aren't very good. I can try and, I don't know, try more ways of explaining it. So I think that's sort of 4s that I can pencil mark in. So let's move on to 5s. Not much going on 5s. I've got 5 locked down in 3 cells here. There are lots of possibilities in the other cages, so I'm going to leave it. Oop, didn't mean to do that. So let's look at 6s. Well, this 6 locks those 2 cells, and that 6 locks these 2 cells. So that gives me a pair of 6s. And these are now pointed pairs looking up at this cell. That 6 locks these 2 cells, and that 6 locks that cell. That gives me another pair. And now these 2 6s actually locks a pair of 6s up here. So now they act as a pointed pair. So I could have, if I'd done that first, I would have already placed a 6 in this cage. But in this case, I'm just going to use them to erase the pencil marking 6 over here, because I know it can no longer be in this row anymore. So now, this is the advantage of Snyder notations. Every time you take out a pencil marking, knowing that you've only got 2 candidates and 2 pencil marks for a number within a cage, if you erase one of them, the other automatically becomes the confirmed number, basically. So this is why Snyder notations are quite popular, because with a minimum amount of pencil marking, you tend to be able to do a lot of solves, basically. So let's move on to other 6s. So this 6 and that 6 locks a 6 up here. So now these 2 6s looks back down, along with that 6 locks a pair of 6s over here as well. So now these 2 6s and that 6 locks a pair of 6s there. And let's move on for now. 7s, I've got these 2 7s locking a 7 down here. And let's see, I think that's all I can do with the 7s. So let's move on to 8s. I've got a pair of 8s up here. I'm going to speed up just a little bit for now, because I'm just going to look at the numbers and pencil mark them in. And I will still point at the numbers, mind you. So these 2 8s locks a pair of 8s here. So now that forms a pointed pair of 8s, locking these 2 columns. I've got another pair of 8s here now. And I think that's all the 8s I can pencil mark in. Let's move on to 9s. I've got a pair of 9s there, and a 9 up here, so that's a pair of 9s pencil marked in. I've got lots of 9s actually, so this 9 and that 9 also locks a pair of 9s there. So now they form a pointed pair again. So I can lock down a pair of 9s over here because of this 9, that 9, and a pointed pair of 9s. So finally, I've got these two 9s and that 9 locking a pair of 9s up here. So now I've done a round of Snyder notations, and we haven't finished the puzzle yet, but we can do a lot now. So anyone who's a bit more advanced would have noticed that I've ignored the 1s and 4s and the 6 and 9s so far because I wanted to leave it till now to actually explain what effects they have. So these are called matching pairs, where when you have two numbers occupying the same two cells within a row, column, or a cage in this case, they basically mean these two cells are the only places that these two numbers can exist within the dimension that we're talking about, basically. So in this case, the 6 and 9 can only go in these two cells within this cage, but it's also valid within this column as well, because the 9s can't go there, and the 6s can't go in any of those cells either. So what does that give us? Well, if we think about it, if the 6 is in this cell, then the 9 has to be in the other cell. And if the 6 is here, the 9 has to go there. That means no other numbers can now enter these two cells. And that's useful because that means I can ignore these two cells now within this cage and just look at these 3 cells as a set of 3s, basically. So let's think of what they are. I'm missing 2, 3, and 7s in this cage now. So I've got 3 here looking down on these two cells. Well, the 3s, I know they can't go in these two cells by the matching pair, and they can't go in these two cells. So suddenly, I can place a 3 in this cell. Similarly, not similarly, but as a result of this 3 being placed, I can lock a pair of 3s down here. Can I do more with it? Nope, I can't. But yeah, that's how matching pairs are useful. Basically, it eliminates any other cells, any other numbers from entering the cells. So I basically eliminated 2 cells from the 3s, which is great. So what else can I do? Well, in this column and a cage, I've only got 2 cells left because the 1 and 4 are locked down as a matching pair. So that basically means I only have 2 cells left in this column, although they happen to be in the same cage anyway. So these are 2s and what's the other number? 7s. So 2s and 7s have to go there. So now 6 and 9 are locked in these 2 cells. That means only these 4 cells are available for, only these 4 cells are free to move about basically. So no other numbers can go in these 2 cells. So normally I don't attack the areas with 4 remaining cells, but for fun, I'm going to have a look at them. So what numbers can fall in these 4 cells? I know one of them is an 8 because I've got the pencil marking, but I've also got 1, 3, so 1, 3, 8, 1, 3, 7 and 8. Okay, so 1, 3, 7 and 8 have to occupy these 4 cells. Well, I've got 1, 7 and 8 over here, so that means that has to be a 3 then, because it has to be 1, 3, 7 and 8 in this row, but I can't put 1, 3, 7 and 8, sorry, 1, 7 and 8 in this cell. And remember, 6 and 9 are already taken, so 3 now goes in here, and that's useful because now these 2 3s locks a pair of 3s down here as well. But I've already got a 3 up there, so that actually gives me a 3. So now these 2 3s gives me another 3 over here, and I've just erased a pencil marking for 2, so that means the 2 has to go here. And now this 2, along with that 2, locks another 2 here, and this 2 unlocks the 2 over here, erasing a 7, so 7 has to go here. So suddenly the puzzle is falling into place. So now I've got 2 cells left on this row. We consider this a weak area. I call it a weak area any columns, rows, or cages with just some 2 or 3 numbers left, basically 2 or 3 candidates or cells that are empty remaining. So 4 and 8 have to go in one of these two cells. Well, I know the 8 can't go there because I've already pencil marked the 8 in these two cells. So that means that has to be a 4. And this has to be, and this can't be a 4. This has to be an 8 now on this row. So let's put the 8 in, and I can erase the pencil marking of 8 up there as well. So now these two 8s locks a pair of 8s in there. So that's useful. So let's look at other weak areas. We have 3 cells left, and they are 1, 7, and 8. I've got 1 and 7 looking into this cell, so the 8 has to go in here basically, because 1, 7, and 8 have to go in these 3 cells. Can't be 1 or 7 here, it has to be an 8. So now I've got 1 and 7 left in these two cells, but I can't see any 1s or 7s on the columns. So I can't pencil mark them in. I can't confirm what they are. So I'm just going to look at this cage. I've got 2 cells left and they're 1s and 7s, so I'm going to pencil mark them in. I'm not going to pencil mark 1 and 7 here, because if I do that, I have to pencil mark in the other possibilities for 1s and 7s as well, to keep to the 2 candidates, 2 pencil markings per cage. But I think we can do more. Let's see, we've got 2 cells left in this column. So what are they? They are 4s and 5s. I can't tell what they are yet, but I can pencil mark them in because it's 2 numbers within a cage. So quite comfortable pencil marking them in. So with the 4 and 5, I've only got 4 cells left within this cage to play with. So let's have a quick look and see if we can do anything with that. So 1, 2. Okay, so 2s are locked down in these 3 cells. So the 2 has to go here, and that has the further effect of these 2s, and that 2 locks another 2 in here. And now suddenly all the 2s are done. I've got 3 cells left now. So 1 has to go in these 2 cells because that 1. What else am I missing? I'm missing 7 and 8 as well. 8 sees that cell, so 8 has to go in here. Actually, why don't I pencil mark them in? And finally 7. 7 can go in any of the 3 cells, so we can't pencil mark them in. We'll leave them alone for now. So what else can I do? I've got another 3 cells here, so let's look at this. I'm missing 4, 7, and 5. So can I see any of those numbers? Nope, not in the rows or columns, so that's disappointing. So I think we might have exhausted weak areas in terms of 3 cells. Now we can expand it to looking at 4 cells at a time. So why don't we have a look at this row? I'm missing 4, 8, 7, and 5. 4, 8, 7, and 5. So it looks like 5s and 7s are not being very helpful because